Hey 13 diplomas, and welcome to your topic 8 recap part E, final part for this, and this is on acid deposition. Okay, so first of all, acid rain, or just rain in general actually. First of all, rain in general is slightly acidic, and the reason why is because carbon dioxide in the atmosphere reacts with water to form carbonic acid. Okay, so all rain is slightly acidic, and then carbonic acid can then break apart into H plus and hydrogen carbonate ions, producing H plus ions. Okay, so all rain is slightly acidic. Okay, so what makes something acid rain? Well, rain becomes acid rain when it's got a pH of below 5.6. Okay, so below 5.6 is acid rain, 5.6 and above is just rain. So how do we get a pH of below 5.6? The main contributors are your sulfur and nitrogen oxides. Sulfur oxides come from burning fossil fuels, and nitrogen oxide comes from the combustion car engine. So what is acid deposition? So acid deposition is when acids in the sky that are formed from these SO2 and NO2 and NO oxides, it's when they react to form acids in the atmosphere, and then those acids fall to the ground. So wet acid deposition is when they fall to the ground in wet form, so in the way of rain or snow or dew, so as aqueous forms, whereas though dry deposition is when the acid particles and gases fall to the ground and then dissolve into water bodies on the floor, on the ground, you know what I mean. Okay, so you can see here's a picture showing dry deposition and wet deposition. You've got your sulfur and nitrogen oxides, and if they come straight down as gases and then dissolve into water that's already on the ground, that's dry deposition. However, wet deposition is when they react with water like rain or snow like that and drop to the ground already as an aqueous solution. There are lots of equations on this page. You don't need to know all of them. I just highly recommend memorizing the easiest ones for you, but this is showing you the reactions. So SO2 is produced from the burning of fossil fuels. Now, I do think you should know that, okay? That's one of the biggest things, and it's one of the biggest pollutants, okay? So sulfur is actually often in the coal that is burnt. Okay, so sulfur plus oxygen forms SO2. Now this SO2 is the problematic thing, because SO2 can react with water, so wet deposition, or if it comes to the ground, dry deposition, so water, key thing there, and it can form H2SO3, which is known as sulfuric acid. Okay, the other thing that can happen is that the SO2 in the atmosphere can react with oxygen to form SO3, and SO3 then does a similar reaction as water to form sulfuric acid. Personally, I think it's quite easy to learn these two equations in particular, that if you add water to either of them, you get H2SO3 or H2SO4, sulfuric acid. And these acid particles are what reduce the pH of acid rain, making it classed as acid rain. So nitrogen oxides, so you've seen this before. Nitrogen that is produced and oxygen react together, to produce two NOs. NO is nitrogen oxide, and this is a toxic gas, a bad gas that we don't actually want. And this here, you can see the NO that is produced can further react with oxygen in the atmosphere to produce NO2. Okay, now NO2 can then further react with water, just like we saw before with our sulfur oxides, okay, to produce HNO2. Now HNO2 is nitrous acid, but it also forms nitric acid, HNO3. So this is probably one of the key equations that you should know for this. You can see up here, how do we actually or how else can NO2 be produced? Because NO2, I've just explained, is using straight from this NO. But NO can actually be produced in the atmosphere as well from oxygen reacting with nitrogen molecules. So there are two ways, but this is the way that's being produced from humans, okay, using burning fossil fuels. in the car combustion engine. So that NO can react with O2 to form NO2. Okay, that NO2 reacts with water to form HNO2 and HNO3. So I guess the main thing to remember here is water, that for acid deposition, there needs to be some form of water, whether it happens in the sky or it happens on the ground. Those substances have to react with water, and they produce your strong acids that you've seen before. So nitric acid is a strong acid that's produced from this. Nitrous acid you might be less familiar with. And just to go back to recap the ones we were looking at before, so when sulfur dioxide and sulfur trioxide react with water, you get sulfurous and sulfuric acid. Okay, so what are some of the effects of acid deposition? So acids react with calcium carbonate. Now, calcium carbonate is a relatively insoluble substance, and when it reacts, they end up producing soluble salts. And so this causes a lot of, so if you form a soluble salt, which I'll just show you an example of an equation here. So I'll just show you this middle one. This is calcium carbonate reacting with sulfuric acid, which we've previously seen how is formed, and you get calcium sulfate, water, and carbon dioxide. Calcium sulfate is soluble, which means that it washes away. And if you think about all of your limestone structures, so loads of structures around the world are made of limestone, which is calcium carbonate, and if acid rain hits them, then they start producing these soluble salts and they start disintegrating. The gargoyles in the famous Cathedral of Notre Dame, they're all disintegrating year after year from this exact type of erosion, and there's very little we can do. And you can see here the calcium carbonate, it'll react the same with nitric acid, another strong acid, to do the same. This top reaction here, this is kind of like a two-step way of doing this, because if you remember before, it's just a little bit more complicated. This is them reacting sulfur dioxide and oxygen to do the same. I probably wouldn't worry about this top equation. I'll just focus on these two because you actually know them. You've done them since year 9. It's just a new application. So acids can actually react with metals in exactly the same way. And so if you, again, just look at this middle equation, which is the easiest, like iron, for instance, can react with sulfuric acid and it produces iron sulfate and water, and iron sulfate is soluble. And again, you've got an issue. So it's leading to the disintegration of iron, and iron's going from Fe to Fe2+, so it's just disintegrating away. And again, substances like aluminium oxide can react with nitric acid and it forms aluminium nitrate, a soluble salt. I don't think you need to memorize these at all. These are just me going through some situations. Aluminium oxide, you may not be aware, that's actually how most aluminium exists. So your aluminium tin cans that you drink out of, your drinks out of, are aluminium oxide. Aluminium's highly reactive with oxygen and immediately forms this layer of aluminium oxide. So all aluminium that we actually use has this layer of aluminium oxide on it, and so that's what's reacting with the nitric acid. And so here's some pictures of, so here's the gargoyle at Notre Dame, and here is the Colosseum, and it's made of limestone. It's just disintegrating away. So impacts on the environment. So acid rain can cause death of plants, okay? It can cause some of the minerals in soil, as we've been talking about. If those substances are insoluble and then they react and they form soluble products, they'll wash away before they can be absorbed. So that process is actually called leaching. If magnesium is removed, plants can no longer synthesize chlorophyll, which is quite problematic. Acid rain can also produce Al3+, in the process that we just saw before, and that can damage the plant roots. And also dry deposition, when the gases come down, they can block the pores of the leaves. So in essence, if you're asked what's an impact of acid rain to plants, you can actually say that it can cause death of plants, and then you get the mark. You don't have to worry about the rest. So what about impacts to water bodies like lakes? So lakes become more acidic because we know that the acid will dissolve into them and form aqueous solutions. An interesting thing is that a lot of rocks have aluminium ions locked in them in an insoluble form of compound. And unfortunately, when the acid reacts, the aluminiums become soluble and leach out in acidic conditions. So aluminium oxide trapped in rocks can react with H plus ions, and these Al3 plus ions come out. And the real issue with that is Al3 plus ions actually stop the gills of fish working properly. So that's one big issue with water bodies, is the aluminium ions getting released from rocks, and that harms fish, and they're not able to take in oxygen. Human health, well, there's not a great correlation there, actually, to be honest. It's mostly the environment. It has been shown that small particles, if they're inhaled, can irritate people and cause asthma and things like that. And the release of some metals like Al3 plus copper and lead can actually be toxic to humans, but this is they're produced in low amounts, so I'm not sure how significant that last point is. I actually don't know the stats on that one. So how can we reduce SO2 and NO emissions? So this slide's talking about SO2 emissions from fossil fuels. So a lot of research has gone into how we can remove the sulfur in coal prior to it being burnt. So that's one way. And another method is post-combustion method. So once it's been combusted, they use smoked stacks to remove the SO2, and what that means is they basically do side reactions to produce harmless products or neutral products. So for instance, they react calcium oxide with SO2 to produce calcium SO3, and calcium then reacts with the SO2 further, and then for the last time till you get calcium sulfate. These are a series of reactions, which is a neutral product. So this is quite a cool technique, and we do this at Glenbrook Steel Mill. They use this post-combustion method to remove SO2 afterwards. So they do a series of reactions to produce neutral products. So really cool. What about nitrogen oxide? How do they stop that? Well, we've already looked at catalytic converters a little bit when we talked about catalysts. So the hot gases are mixed with air and passed over a platinum catalyst, so platinum providing the surface here. And so the NO will react with CO, and you end up producing CO2 and N2, which are both harmless and already in the atmosphere. So catalytic converters have been huge at helping convert nitrogen oxide into less harmful gases. The other thing is a lower temperature of combustion. So the formation of NO is reduced at lower temperatures. So if we can recirculate the exhaust gases back into the engine, it lowers the temperature, and we get less NO produced. So there's a lot of research into this stuff, because until we stop using fossil fuels and we stop using petrol, we're going to have these issues, which are the most harmful to our environment. The final slide is, a lot of our water bodies, a lot of these lakes in certain countries are now becoming quite acidic. And one technique that they're doing, and I can't remember where this is, sorry, I'll have to find that out for you, is they're actually dumping a whole lot of calcium oxide and calcium hydroxide into the water bodies to produce, into the lakes and rivers, to produce calcium sulfate, which is a neutral product. So they're literally just neutralizing by adding a chuckload of base in there, which is pretty cool. So all in all, the key things for acid rain is the fact you've got to understand that it's nitrogen oxides and sulfur oxides that are causing it. Okay, when a pH is less than 5.6, it's considered to be acid rain. These substances react to form strong acids, and these strong acids can then impact the environment in multiple ways, as we've discussed. And this is the end of your topic 8 acids and bases recap. I'll see you shortly for topic 18.